the origin of the moon. We've talked about the moon a lot, but we haven't really talked about how it got there. So we started the week, I showed you guys this family portrait. So Mercury, Venus, Earth, Mars, they're all planets. And then we have the moon. And the moon, you can notice, is pretty unusual if we're thinking of our inner solar system, our rocky worlds, in that there's no real equivalent moon in the rest of the inner solar system. So basically, I mean, it's a quarter the size of Earth or so, but stop it. But like Mercury, Venus, Mars do not have moons that are a large size compared to their own planet. Mars has 2 moons, but they're just little asteroids that have been captured, so not really anything significant. So there's 4 main hypotheses, though, for then how the moon came to be. The first is fission. So the idea that as the Earth was forming, the moon calved off of the Earth and became its own thing. The second is that it was a sister. So it was formed around the Earth as the planets were forming. Then we already had the moon forming separately from the Earth, but already gravitationally bound. And then so it just accreted and ended up being the moon. Capture. So there was a planetesimal, and then it came too close to Earth's gravity and was captured by the Earth. So it's just another captured planetesimal. Or the fourth is a giant impact, that the moon coalesced after a gigantic impact between the Earth and a planetesimal roughly the size of Mars. I could tell you right now, so we've had these hypotheses quite a while. The current leading theory is this last one, that the moon was formed by a giant impact very soon after the start of the solar system. So as I said, it would have been a Mars-sized impactor called Theia, often in these simulations and things like that. Basically crashed and impacted, like we've talked about how things are created, then created some sort of gigantic debris of disks, and then formed eventually into the moon. Probably, a process no longer than, say, 1,000 years or something like that. It would have been a relatively fast process for this to happen, but it would have been a pretty crazy impact. I have a simulation from NASA, and I'm going to show you guys on how this worked. So this is the Mars thing, Theia, and that's the Earth. Basically, the Earth would have been completely obliterated when this impact happened. And you suddenly have all this ton of this material from the Earth and from the planet that is thrown out into outer space. You have all of this debris. You probably would have even had like a ring, like Saturn-like, around Earth for a very short period of time. You have a lot of stuff still going in and impacting, everything like that. So this would have been a pretty crazy collision. But at the end of it, what we end up having is our moon. So that's a very nice thing to have. So watch, I think it's just the same simulation again. They're showing that, yeah, simulations are crazy, or impacts are crazy. And let's see, is it almost done? Yeah, so part of it goes back in. This part is going to end up becoming the moon. And we believe this is how the moon was formed. Okay, so this would have been very soon after the initial formation of the solar system, 4.5 billion years ago or so. By soon, I mean like 60 million years after the solar system formed. So not soon on our time scales, but in terms of a solar system that's 4.5 billion years old, it would have been quite soon. And another thing that ends up happening once you form the moon is the rotation period over time. So the rotation period of the moon is going to then match that of the Earth. So we talked earlier, it's about 27 days for the Earth, for the moon to go around the Earth. It is also comparable to the spin period of the moon. If you were to measure a day on the moon, it's pretty much the same as an orbit. So what this ends up meaning is that, yeah, they're tidally locked. And it also ended up impacting our formation of what the moon looks like. The side that always faces us is the side that has the mare, like in the picture. And we think that has to do with the fact that this side was facing Earth all the time, more gravitational tidal forces from the Earth impacting the side of the moon, versus the other side, which is very cratery, does not really have many mare on it. The other thing I should emphasize, the fact that the moon ended up existing is probably pretty important for life to exist on our planet Earth. So we discussed the tides and how the tides are formed. Tides are very important. If you think about, if you've gone to the coast, you've seen the tide pools, things like that. So when life would have had to come out of the oceans in order for us to be able to walk around evolutionarily, probably that happened in this tide pool type area where you first have life trying to come onto the surface. The other thing is the moon is actually, because of the tidal locking, slowed us down quite a bit in terms of the Earth's rotation as well. Earth's rotation, 24 hours a day now. If we didn't have a moon, it would be a couple hours. So something like 8 hours or something. We don't know exactly, but it would have been an 8-hour day instead of a 24-hour day. So beyond just, okay, that's much less than what we're used to now. You probably would have more extreme weather conditions if the entire planet was spinning faster than it is now. If you think about the atmosphere and how that would be affected. So it's probably a good thing for us that the moon exists for life as we know it to exist. I'm not saying life couldn't have existed without a moon, but I think it's fair to say that it would have looked very different. So just a final thing, I'm sure everybody has exciting plans tonight, so we'll wrap this up early. As I said, so this is what I was showing on the globe, but it's probably easier to see here. So the near side, we have the mare. The far side of the moon, it's just a cratered mass. It's not that interesting. But I will just say, sometimes, apologies, hear the far side referred to as the dark side of the moon. It's not that it's physically always dark there. I mean, you guys now know because of how we know how the phases of the moon happen, that there's some times where it's sunlight on that far side. It's more that that far side is never visible to Earth. And until modern space flight existed, we actually didn't know what the far side of the moon looked like. So people call it the dark side of the moon, just because there were a lot of wild speculations on what could be back there. So this is kind of the quick general story of how the moon formed, why we have the mare on one side. Basically, it all has to do with this giant impact, which is pretty unique as far as we can tell in the entire history of our solar system.